Okay, hi everyone. It's Jack Cork again, Math 152, Section 4 with Professor Ellis. And today we are going to be talking about improper integrals. These are integrals that either have undefined points on their domain or things like negative infinity and positive infinity as their bounds. We're going to take a look at all these cases. Hopefully, a better understanding of how to do these problems. When we're done here today, again, I apologize for my voice. I'm a little under the weather, but I digress. So, first problem we'll be covering is the integral from e to infinity of 1 over x ln x to the third dx. Now, right away, we identify this as type 1 bounded by infinity. So we know that we then take the limit of some arbitrary variable b that approaches infinity of the integral from e to b of 1 over x ln x cubed dx. So here we can see this is a simple u-sub problem, given that the derivative of ln x is 1 over x. So we set u equal to the ln of x, du is 1 over x dx, which simplifies this limit as b approaches infinity of the integral from e to b of 1 over u to the third du. So this is a basic power rule. So to find this integral, we get the limit b approaches infinity, evaluated from e to b of negative 1/2 ln x squared, subbing the u back in, which is equivalent to the limit b approaches infinity of negative 1 over 2 times b squared plus 1 over 2 times 1 squared. Now, this limit can be taken in two parts, evaluated first here and then here, and we just take the sum. As b goes to infinity here, the denominator gets infinitely larger, and this number gets closer and closer to 0. And here we just evaluate this expression 1/2. So 0 plus 1/2 means that the limit as b approaches infinity is equal to 1/2. Meaning that this improper integral converges to 1/2. Okay, so get rid of all this here. Next problem we'll be looking at is basically the reverse of what we just covered. In this case, we'll be taking the integral, except our starting condition a will be negative. So, for this problem, we have the integral from negative infinity to 0 of the expression 1 over 3 minus 4x dx. Okay, so we have this negative infinity here. We do the same thing, but in reverse. That's the last problem we covered. And we take the limit and some arbitrary variable. We call it b goes to minus infinity. And the integral from b to 0 of 1 over 3 minus 4x dx. Now again, you can see here that this is a u subproblem. Just let u equal to 3 minus 4x. Take the derivative with respect to u, and get negative 4 dx. Which means this limit as b approaches minus infinity, taken from negative 1/4 integral b to 0, 1 over u du. Now it's will then be evaluated to a simple ln. Bring it down here, the limit as b approaches minus infinity, negative 1/4 comes out front as a constant, evaluated from b to 0 of the ln of the absolute value of u. So evaluate this expression at point 0 in b, and we get the limit as b approaches minus infinity, negative 1/4 times the expression ln, the absolute value, plugging our u back in. We have 3 minus 4 times our initial condition, our b condition, sorry, 0, minus the ln of absolute value 3 minus 4b. So we're taking the limit here, and just like before, we can evaluate the limit. Two different parts of the expression to make it easier on ourselves. So negative 1/4 ln 3, 4 times 0 is 0, so the ln of 3 plus the limit as b goes to minus infinity of the ln of 3 minus 4b. So this limit just approaches negative ln 3 over 4, and we add that to this limit, which approaches 3 minus 4 times negative infinity is equivalent to 3 plus 4 times infinity, which is equivalent to infinity. And the limit of infinity, well, it's just going to go to infinity. So since we still have this undefined term here, this tells us that our given limit is divergent. By extension, the integral does not exist. Okay, so we've got one more problem here for you today. Just another example of a type 1. Okay, let's take a look at this last problem. We have the integral from 0 to infinity of the expression squared over the square root of 1 plus x raised to the third power taken with respect to dx. So, just like before, see that this is approaching infinity, which means we can express this as a limit as our arbitrary variable b goes to infinity. The integral from 0 to b x squared over the square root of 1 plus x to the third dx. Once more, you can see that our integral can be evaluated using a u substitution, letting u equal to 1 plus x to the third. Take the derivative of the u, and we get 3x squared dx, which means our limit can now be expressed as the limit as b goes to infinity of the integral from, and this time we're going to leave it in terms of u. We don't often do that, but it's just one less step on the back end and one more step right now. So we'll plug our 0 into our u, and we'll get 1. And we'll plug our b into our u, and we'll get 1 plus b raised to the third power. So not particularly different, but in this case we now have u negative 1/2 du. Evaluate this, one more thing, times 1/3. Sorry about that. So now we evaluate our limits, basic power rule. So b approaches infinity of 1/3, evaluated from 1 to 1 plus b cubed of u to the 1/2 over 1/2, which is equivalent to the limit as b approaches infinity, 1/3 times the expression 2 square root 1 plus b to the third minus 2 square root of 1. Now evaluating this limit at the two different parts of the expression, we get the limit as b goes to infinity of 2/3 square root plus b to the third minus limit as b approaches infinity 2/3 excuse me, times the square root of 1. So our second of the limit expression goes to a value of 2/3, and it is being subtracted from the limit as b goes to infinity of 2/3 root 1 plus b cubed, which b cubed is infinity, so this limit is just going to go to infinity. Infinity minus 2/3 is still infinity. So we know that this particular integral diverges. All right, so that's all I've got for you today. Appreciate you showing up, and that will be all.